Friday's test is mostly multiple choice with a little free response. Yes? You must show your work. And Tuesday is the partner test with a calculator. Not necessarily. It has a calculator. This is without a calculator. And this is 2 free response questions.
You check the partner test that the other test that's 1 and Skyward?
No, they're separate tests in Skyward. No. Your final is your final. Okay. So, what did we do in Chapter 4? I will put that link on Schoology because he talked about everything. I don't really want to say 4.1 did this, 4.2 did that. 4.1 through 4.3 is really a summary of everything. First thing we started off with was the max-min existence theorem. Do you remember what that is? Well, we have to have a what? Yes.
Continuous on a closed interval.
F of x is continuous,
On a closed interval.
and it has to be a closed interval. And then, once I know that, if they're asking for a maximum or minimum value of the function, I can use this theorem. And so this is a guarantee of both a max and min. Exist. Okay? Jay? Carter, where do they occur? Where would you look to find the maximum? We would look at the critical points. What you don't like about the theorem, I think, is that first you have to decide if it applies. You have to know that it guarantees both a max and min. And then you have to think, okay, where would that happen? Where would that happen? Where are the critical points? F prime is 0. F prime is undefined. And at the endpoints. And how do you know if you have, which one of these gives you a max or min? How do you know? You evaluate. What do you evaluate? The derivative or the function? The function. The only calculus involved in this, hey guys, shh, the only calculus involved is finding the derivative, finding it where it's 0 and undefined. And actually finding where it's 0, once you've taken the derivative, is algebra. This is algebra. You just look at the function. Where does it have its maximum value? What is the maximum value? Defined. Now make sure you answer the question. Because sometimes they ask, where does it occur? Sometimes they ask what it is. And what it is actually the value of the function. Okay.
Can you do an example of that, though?
Yes, I'm going to give you back your quiz. And that extra credit problem uses the max-min existence theorem. So, you're going to find your function. You're going to evaluate it at your endpoints. I always do the easy things first, if I can. And then you have to find the derivative, set it equal to 0. And then you find where those are. I'll tell you there too. And put it back into your function and see which is biggest. And I'll allow you today to use a calculator, but it is a non-calculator question.
We do one where there's no endpoints.
If there's no endpoints, then we can't use this theorem. Then we have to just do a first derivative test or a second derivative test. So, what did we learn in this section? These sections, we learned that if f prime is positive, what's true about f? And if f prime is negative, then f is decreasing. Okay? What else do we learn? Yeah, what's f double prime? Okay. They're just using it to watch. Splash top.
What?
Splash top. Okay, you guys. No. If f double prime is positive, my function is what? Concave up. If f double prime is negative, it's down. They find it? And hopefully it matches. And if it doesn't match, I have to do something. I can do it here. I'll get it fixed. Okay. That doesn't make sense either, but anyway. Okay. What if I want to find max or mins with a first derivative test? Whoops. Here is f prime. Now I use this to help. He talks about this little line graph. If f prime goes from positive to negative, what has to be true? My function would be increasing. So this would be a max. Now, the only way to know if you have an absolute max or min is to look at the graph. So they're not going to give you a situation, put you in a situation where you can't find the absolute max or min. And that's what you say, f prime, positive to negative, right. This could be 0 or it could be undefined. Right there.
Like setting it up on a number line.
You just have to test it. You find where it's 0, test it. I'll let you do that with problems.
Like x squared. X squared.
What's the derivative? You can do x squared.
There's 2x. Okay. Now,
So if y equals x squared, then y prime is equal to 2x. Where's the critical point?
the critical point is at 0.
0 equals 2x. And then you try a number to the right, like 1. This is positive. And this is, if I try a number to the left, this is negative. And what happens here?
Negative, positive, you have a minimum.
Okay, so f prime is going from negative to positive. Therefore, we have a minimum. Because my function would be looking like this. I have not memorized this.
A minimum. And is it going to be concave up?
Yes, it is. We haven't gotten there yet.
Is out there, you can-
Yes? This is the first derivative test. You guys? And since I have it here, we'll look at the second derivative test. Ellie? No, they have to give them to you. Okay, second derivative test. We're almost to the second derivative test. Okay, when you do the second derivative, we'll get there. When you do the second derivative, if the second derivative is positive, then my function is concave up, and I have a minimum. It's like what I have over here. Okay, guys? Well, I want to get this done. If f double prime is negative, then it's concave down, and it's a maximum. How do I find inflection points? And inflection points occur. F double prime is 0 is a candidate. Also, F double prime is undefined. Those are candidates. And how do you know if you have an inflection point? F double prime was what? Change sign.
For the first derivative test, you can find the second derivative.
No. First derivative test is when I do this little line graphs. Second derivative test, guys, is when I find the sign. So I'm going to write this. Second derivative test. First, you find your critical points. So you still have to do a first derivative. And then you find the second derivative. And you evaluate the second derivative at those critical points. F double prime at the critical points. Okay, if it's positive, you have a minimum. If the second derivative is negative, you have a maximum. But I draw the pictures every time. And that's the bulk of what's in this chapter.
So that, all that is included in the second derivative.
This is the second derivative test in blue.
That double prime is positive, that it's going to be.
A minimum. Okay?
Did you do this for x squared? Did you do this?
X squared, what's the second derivative of x squared?
It's going to be 2.
2, which means that it's concave up and we have a minimum.
What if it's, let's say, x cubed? So the
There is no maximum min for x cubed.
second derivative test would be
So y equals x cubed, y prime is equal to 3x squared, and y double prime is equal to 6x. It's 0 here at 0. So if you do y double prime of 0 and you get 0, you know nothing. You have to get a positive or negative to really know. Second derivative test fails. Doesn't work out every time.
What did you say?
You have to do a first derivative test.
Think you do
And if I do the first, if I do the first derivative test, it's always positive. Is there extreme value there? It's always increasing. What happens at 0? We get a change in concavity. So if I do a second derivative test, if I go to the right, it's positive, negative on the left.
negative to positive.
Any change of sign? Question. I don't know. I want to finish this up.
The value will have to have right.
Right. And then you have to look to see if I'm not going to write it again. It's right here.
Yeah, we set up the equation like f double prime 0, and f double prime.
What if y equals x to the 4th? Y prime is 4x cubed. Y double prime is 12x squared. And again, you have the same problem that y double prime at 0 is 0. I know nothing. And there is a minimum here. See, y double prime of 0 equals 0. This function looks like this. But it's not flat, but it's, so yes, you do have a minimum. So second derivative test fails there. On the cubic one, there's no maximum. First derivative, I mean, you're going to use the first derivative test 99% of the time.
It would fail though.
No, first derivative test is fine.
So the first derivative test itself for 0.
Yes, and it's 0 at 0,
The 0 at 0.
and it's a cubic, so it's positive here and negative there. Therefore, it's a min. Okay, that's 4.1 through 4.3. I have little to say about 4.4. 4.4, you can go watch the video again. That is the optimization. That's what the extra credit problem was on that quiz. It says when is, I'm going to have you guys do it, the particle furthest to the left. Am I looking for a max or min? Min. I'm going to tell you, it's a closed interval, max min existence theorem. So you're going to just evaluate the function at the endpoints. And there are 2 critical points. Some of you only found 1. Use your calculator so you believe me. Find max and mins. It's maximizing or minimizing something. Okay, Grant. Shh, girls. Okay. Section 4.5. No, we don't have that time. Section, you have to go back and watch the videos. All the examples are there. Okay, guys. Section 4.5 is the differentials. And all the videos are there. This is when you find dy. You find errors in the area. Also, we had linearization. Grant.
Go.
Please. Sistering to other people. Not to mention me. Okay, that's writing the equation of the tangent line. Okay, and then 4.6 we just quizzed on related rates. Okay, that's what chapter 4 is. So 1 through 3, Ricardo, 1 through 3 is just talking about f prime, f double prime. What does it tell you about the function? What does it look like? And these are the actual applications. Why would I care about derivatives? I want to minimize my losses in my business. I want to maximize my profits. So that's where you use it in calculus in a business class. Then 4.5 is just approximations, and 4.6 is the related rates. Seeing how things change. And again, you probably do that in engineering and physics. So the rest of the time, I'm going to give you back your quizzes, and you can ask me some individual questions, or we can come back and do an optimization problem. But first, I want you to have your quizzes back. They go in, nope, in the little.
Hey!